Okay, in this video, I want to talk about a concept known as present and future value. Essentially, what we're talking about here is the beginnings of financial analysis and something that we're probably all familiar with to some extent. So, here's a basic question. Is the money worth more to you today than the same amount in 3 years? Well, essentially, we've always have experienced this in many shapes or forms, but we know a dollar today isn't worth a dollar a few years from now. So that's due to either a discount rate, let's say inflation, or some sort of growth rate. Maybe we're talking about investments where we are actually making a percentage. So let's start talking a little bit about some of the concepts related to present value and future value. We often abbreviate present value as PV, future value as FV, and when we talk about the rates, usually we either term this as a discount rate, meaning your money is worth less over time, or perhaps a growth rate where it's actually gaining you money. N will be the number of periods. Usually this is in terms of years. So if we give you a rate that's, let's say, 8%, that's annual. And it's important to keep these units the same. So if a rate's given to you in years, you should do your analysis in years. And in some situations, if it's given to you in years, maybe we want to do a monthly analysis, perhaps a credit card type of analysis. Then we have to divide the rate by the number of years and things like that. So I'm going to keep this relatively low level in our discussion, but I wanted to show you some functionality in Excel. So in terms of the formulas, the formulas are pretty straightforward here. Anytime we want to calculate a present value, it's going to be equal to the future value divided by the term in parentheses 1 plus r to the nth power. So all of that is then the denominator. When we talk about the discount factor, what we're talking about is essentially everything in the denominator where the numerator of the future value is 1, and we'll calculate that just to calculate this manually and then calculate it through an Excel formula. If we're wanting to calculate a future value, we have a very similar formula. Instead of a division, we have the multiplication. So we have present value. If we know the present value in the future, we can simply multiply this by that discount or growth factor. Okay, one other concept I want to briefly touch on is the internal rate of return. So the internal rate of return is basically a discount rate that makes the net present value of cash flow equal to 0. So usually what we have is a large investment in what we would term year 0, this current year, and after a heavy negative cash flow item, we would expect to gain money from that, and those are all going to be positive cash flow items. So what we're really talking about is how long does it take for that initial investment to break even, which means a 0 net present value. And I'll show you a demonstration of what I'm talking about when we go through this exercise. So internal rate of return is also used if the internal rate is above your discount rate. Well, then that's going to be attractive. Now you could argue, well, I have a very high standard that I'd like to make at least 20% a year or something like that. So maybe there's some fluctuation there in terms of your decision making. But in general, if the internal rate is bigger than the discount rate, it's going to be making you money at least. Maybe for you, it's not making enough. And that's where some decision would need to be thought about. Okay, so let's go ahead and open up our starting file for this activity. Okay, we see essentially a cash flow statement here where we have year 0, which is going to be quote unquote this particular year. In this particular year, we're going to make $100,000 investment. we are going to expect a return, and I've listed all the values here that we expect to return over time in the 6 years that we have this project, let's just say. So year 0 through year 6, these are already formatted as an accounting value. Okay, so let me get it back to this, a $ format. And $ format, if you have anything in parentheses, that's going to be a negative cash flow item. Anything positive is going to be displayed without the parentheses. So anyway, also appearing in this table is 8%. This is going to be our discount rate for this particular problem. And what I'd like to do is just go through this problem and calculating these net present value a few different ways. So all of these amounts are values that are actually future values. So like I said earlier, $1 today is not worth the same dollar 6 years from now. So these are all representing future values that we would actually like to know what the present value of that 25, let's say in year 6, would be. So we know it's going to be less because we have a discount rate. Okay, so if I was to calculate this manually without the use of an Excel formula, what I would end up doing is calculating this with the discount factor. And that goes back to that formula I showed you on the PowerPoint. So it's going to be implemented like this. It's going to be implemented as equals 1 divided by, and then we're going to have the denominator of 1 plus our rate. Let's go ahead and lock that in an absolute fashion. Parenthesis to the power n. And this might be a little confusing, but n in this particular instance is 0 because we have this 0-year standard that we like to use. So I'm going to simply reference year, and just to be sure my order of operations are calculated correctly, I'm going to go ahead and put parentheses around the entire thing. So once we have this and the $sign's in the appropriate place, we hit enter and we'll notice that the discount factor, in other words, what percentage of these original amounts do we need to multiply by to get the present value, is 1. So that's saying in year 0, the $100,000 is actually multiplied by 1, which exactly gives you the present value of the negative 100,000. So let me just do that multiplication, and this makes sense. So in year 0, any amount we speak of is already in terms of the present day value. Let's see what happens as we fill this formula down. The first year, which would be year 1, the first year return is 20,000. And actually what we're saying is, based on this discount factor, we're really talking about a difference here of roughly 1 minus 0.926, which would be a little less than 8%. So let's go ahead and do that. So the present value, in other words, would be 20,000 times 92.6%. Okay, so that leaves us the present value of $18,518.52. So we can go through these examples. Now we're talking about year 2, and we need to multiply the $30,000 by the 85.7% to get our present value in year 2 of 25. So 30 in terms of the future value is actually worth today $25,000. So let's go ahead and make quick work of the remaining calculations by filling these formulas down. And now I want to talk about doing this either through a manual calculation like we did with an extra column. I could have embedded, let's just say, the amount here right here in the formula where I could have said these are all future values. Let's embed that here, and I wouldn't have needed this extra column, but I wanted to break it down a little bit. So with the extra column, the net present value would be simply a sum of all of the present values, and we get 33,000 $920 and 59 cents. Now we could have done this maybe this way and calculated the net present value with a sum product. Sum product would be all the discount factors, comma, and then the amounts in either order. We could have went with the amounts, comma, discount factor, which probably logically speaking would have made more sense since we're going from left to right. We notice we get exactly the same value, but here's actually the beauty of Excel. We can actually not even calculate the values here in D and E and go straight to an Excel calculation where we can calculate the net present value. So the net present value is actually going to be equal to NPV parenthesis the rate. The rate will be this 8%. Use your dollar signs, comma, value. Now it wants value 1, 2, and 3. Now if we read the documentation on net present value, what this is actually going to say is that it assumes that any series that we're going to put in net present value starts after year 0. So what that means is you're going to highlight everything in your cash flow from year 1 to 6. Okay, that's a little confusing to some perhaps, but that's what you need to do. And we can't forget about this negative cash flow item. We simply need to add this negative 100,000 at the very end. So once we hit enter, we actually get exactly the net present value. Okay, while I'm thinking about it, let's go ahead and move this column over to the right and F to G. And what I want to do is just show you that not only do we have a formula for net present value, we actually have a present value formula in Excel. I'm going to use my format painter here, and I'm going to change this title to let's call it present value with Excel, or well, let's just call it within, or PV, I'm sorry. That's the shorthand for the formula that we're going to use. And this is present value with manual calc. Okay, so we just multiplied this discount rate, discount factor by the original amount. So what I'm trying to say is there's many ways to do this analysis. I'm trying to suggest that doing it with these formulas makes this problem a lot easier, especially once your spreadsheet gets very complicated. We can actually implement this same calculation, so we're going to get exactly the same values as what we have here in the manual calculation right here. So we utilize the PV formula. The rate would be 8%. NPR would be the year. Payment is actually going to be a field that we don't need. Payment is an annual payment, which is in this case an optional parameter. So we just put a secondary set of commas, basically leaving out the annual payment, and we need to reference a future value. Like I said earlier, the future value is really this amount we talked about in column C. So I'm going to put my parenthesis here and go ahead and hit enter and show you that we can do these calculations manually if we wanted to. However, the one thing that is different, we can see the absolute value of these columns is the same, but for whatever reason, the way that the Excel formula is implemented, it has the sign backwards. So oftentimes, we'll simply put a negative PV here and fill this down to match the sign of a manual calculation. Okay, so that is one way of doing it. The final thing I wanted to show you is we can actually do the same exact thing if we have a present value and we actually want to go back to the future value. How would we do that? I would actually utilize a FV formula. FV, the rate would be 8%, dollar sign. NPR would be 0. Payment is going to be ignored, and the present value, I should say, we need to pick one of these columns. Let's just pick the one next to it and end our parenthesis. Let's hit enter, and we're going to have the same issue with the sign. but we can quickly see that these values in G, column G, match that of column C. So we can go back and forth provided that we have the information. I'm going to quickly change this sign to negative FV on the formula and fill this down. So now the columns match in terms of their sign. And maybe if you want to provide a little bit of description here, I know this isn't necessarily the best label since I abbreviated future value and present value with the Excel formula F, V, and PV, but it gives you an idea that this is calculated with a formula. This is calculated with a formula. This is our manual calculation, provided that we knew the formula, but of course, if you're like me, you can't remember a lot of these formulas, and that's why Excel is nice. Before I get to the internal rate of return, I simply wanted to graph this analysis. What I'm going to actually do is highlight label and amount and create a simple column chart. And I'm just going to put this chart, maybe right here is okay. I'm going to do some simple formatting. I don't like how these are angled, so I'm going to right click, go to format axis, and change, let's see, change the alignment to, instead of what it's saying is horizontal, text direction, we're going to put that rotated, and it's going to go straight up and down. I'm also going to change this to match our color scheme we got to a green. And let's see, what else can we do? I'm going to put on a x-axis, if you will. And I'm going to put it below. And I'm simply going to say that this is year. And instead of saying initial investment, first year return, and so forth, I'm going to right click on this, go to select data, and change the horizontal category to our years 0 through 6. I think that looks a little bit better. Amount is not necessarily descriptive enough for me. This is really a cash flow diagram, and that should be enough information there. So what the internal rate of return is the rate of return once you make your initial investment. What is the rate at which you break even? Therefore, when does your future cash flow items equate to this initial investment? Okay, so what rate would that be? We're going to use the IRR function, and we need values, and a guess is optional. Now, the values, let's talk about that. The values will actually be the entire cash flow. So this formula doesn't assume that you need everything from 1 to 6. It assumes you need everything from 0 to 6. So keep that in mind. Let's hit enter. And I just want to bring up one point about this guess. So sometimes it is possible that a cash flow has much more hills and valleys and things like that, where you could have multiple rates of return that would cause you to break even. Something like this would only have one internal rate of return. The guess is there to basically tell the Excel formula what internal rate do you expect, because there might be more than one, and it would return the one closer to the guess. So that's a little bit beyond the scope of what I wanted to talk about here, but it is there, and you have the help file to read more about that if necessary. I'm going to hit OK, and I just want to interpret this. If this was presented to me and the discount rate was 8% and I knew I could make an internal rate of return of 18, I would say that looks good. I'm going to go ahead and give you the 100,000 and reap the benefits of this investment because this internal rate is higher. Just wanted to show you one thing. By definition, the internal rate of return is one that makes the net present value 0. Right now we have a positive, which is great. That means we're making a return. But what if we change this discount rate to exactly the internal rate? Well, it should make all these 0. Let's go ahead and do that. I'm going to copy this 18.1 and paste it here. I'm going to paste values. And we'll notice once we do, we put the 18.1 here. All of our net present values, regardless of which way we calculate them, are all zeros. So I'm going to undo that, get back to our normal setup, and say that if I had to make a decision on this data, I would definitely do the project because the internal rate is much higher than the discount rate.